All right, guys, so we are doing this class opener. You should be able to answer 1 through 4 easily because all you're doing is adding or subtracting polynomials. But there's more to it than just that. You also need to classify it, give it a first name based on the degree, and the last name based on your number of terms. Once you actually get an answer, once you actually combine like terms and you get your polynomial that's simplified, then you classify it, first and last name. And what else? On the bottom over here, this is kind of like the intro to the new section, which is 8.2, and we're simply gonna simplify. You either combine like terms or multiply, right? And there is a big difference when you're adding terms that are alike as opposed to multiplying them. So I want to pause it right now, give you guys a couple of moments to do 1 through 4. I think some of us are struggling with adding and subtracting polynomials. When you add or subtract, when you combine like terms, that's what it is, it's combining like terms. When you combine like terms, that's just adding and subtracting. That's just, you could think of money, right? If it's like a -3, that means you owe $3. If it's a +5, that means you have $5. And then see how you end up, right? It's just adding and subtracting. But you might be adding and subtracting regular x's. You might be adding and subtracting x squares. So the idea is to combine your x squares with your x squares, your x to the thirds with the x to the thirds, the x's with the x's, and the numbers with the numbers. So on number 1, since you want your answer in standard form, that means highest exponent down to smallest. Which is the highest exponent on number 1? 3. Now we are adding, so if you were to distribute a plus sign, nothing changes, so you don't need to distribute anything. As a matter of fact, you don't even need these parentheses or those parentheses because of the plus. You're simply going to jump right into combining like terms. So let's look at this highest exponent term, -2x to the third, and there is no other x to the thirds, so you can't combine it with anything. So that is the first part of your answer, -2x to the third. Then move on to your next highest exponent. What would that be? Is there any squares? Yes, there is. We have this 2x squared right there, and there's nothing else to combine it with. Like if you would have had a 4x squared over here, yeah, you would add the 2x squared with the 4x squared, but it's not an x squared, it's just an x. So there is no other x squared. You cannot combine it with anything else. So we're just going to bring it right down, and that is a positive 2x squared. So far on our polynomial answer, it's -2x to the third plus 2x squared. Now let's move on to the next exponent, which is the exponent of 1, right? We went from 3 to 2. We're going in order. Now we want x to the 1 power. Is there any x to the 1s? Yeah, there's a -4x right here and a positive 4x right there. Now notice that when I circle it, I include the sign that's in front. When I circle it, I include the sign that's in front because that's what tells you if you have or you owe. And right here, you owe 4 of these guys. You owe $4. You have $4. What happens? They cancel out, right? If you owe $4 and you have $4, you could pay them off. You don't owe anything anymore, so those disappear. Now, after that, your very last term should be your constant term, which is a number without variables, if there is any numbers without variables, which as you can see, it's right here, the +4. There is no other number without a variable, so you just bring it down +4. And that's it. Okay? So what do we classify? I mean, this is the answer, but we now need to give it a first and last name. So what's the first name? It's going to be based on the degree, which is 3, which is cubic. So let's write that down, cubic. And last name is based on number of terms, 1, 2, 3. How many terms? We have 3, so what do we call that? Trinomial, cubic trinomial, perfect. So we have our answer and we have our classification, first and last name. I do want to mention this, guys. When we add, like if I say what's x plus x, what is that? 2x, right? Notice that nothing happened with the exponents. Exponents do not change, right? It's not like you had a 1 here and a 1 there and it became a 2 up here. You don't add the exponents. You don't do anything with the exponents. Why not? Because exponents come from multiplication, right? Like if I say 3 to the second power, that's really saying 3 times 3. Exponents come from multiplication. So if I were multiplying, like if I had an x times x, yeah, then it would change the x squared. So when you're multiplying, exponents change. When you're adding and subtracting, exponents do not change. And that'll be very important in a couple of minutes when we get to the bottom half of this opener. But it's even important right now because we are adding or subtracting, right? Adding, subtracting, adding. We're only adding and subtracting. Exponents are not going to change. Got that? Okay. So number 2, it's the same thing. We need to combine like terms, but before combining like terms, before doing x squares with x squares, x's with x's, number with numbers, we need to take this minus sign and distribute it to both terms. So I like to circle it and draw an arrow, and then draw an arrow. So that negative x right here is going to become positive x. And that positive 3, when I distribute it, it's going to become negative 3. Now, some people like to rewrite this down here, or you could simply do what I usually do. I just scratch it out. I don't need to deal with that anymore because I now have it down here. So now I want to combine like terms. I have 7x squared, I have minus x, a plus x, and a minus 3. We're going to start with the highest exponent, and the highest exponent term is the x squared. And there's nothing else to combine it with. This is not an x squared, that's not an x squared, that's not an x squared. So that is the first part of our answer, 7x squared. Now let's move on to the next highest exponent, which is x's to the 1 power, x to the 1 power. So we have a negative x and a positive x, and what happens there? They cancel out, they disappear. So there are no x's on my answer. And then I go to my final term on my polynomial, which should be the constant, just the numbers without variables. And what would that be? Minus 3, and there's nothing else to combine it with. So I just write it, minus 3. And there's my answer. 7x squared minus 3. Now I need to classify it. What is that bad boy right there? What's the degree? What's that first name? The degree is the power of 2, and what is that? Quadratic. Quadratic. Quadratic what? How many terms do you have there? 2 terms. So what do we say? Binomial. Quadratic binomial. Okay? So it's very important that when you have a minus sign between the polynomials, when you have a minus sign, you have to distribute it to that second polynomial. If you had something out here, you'd have to distribute it also. But since there's only a minus sign in front of this guy, you distribute it only to the terms in here. And that changes the sign. So this minus is going to go right there. It's going to become a minus 4x to the 4th. And it's going to go right there. It's going to become a minus 1 instead of a plus 1. So again, you could scratch this out the way I did up here, or you could rewrite this down here so it'll be at the same level. I might as well do that. Switch it up a little. X to the 3rd minus 2x. And now we have 4 terms right there. And we're going to start with the highest exponent term. What's the highest exponent term? Negative 4, x to the 4th. And then that's the power of 4. And there was nothing else to combine it with. There are no other x to the 4ths. And now let's move on to the next highest exponent term, x to the 3rd. Is there any other x to the 3rds? No. So I'm just going to write it as the next part of my answer, which is positive x to the 3rd. Okay, and what else? We move on to the next highest exponent. Is there any x squares right here? Any x squares? No. Is there any x's? Yeah, it's right here, the negative 2x. Am I able to combine it with any other x? No, there's no more x's. It's just that one negative 2x. So let's rewrite it, or let's put it on our answer, negative 2x. And last but not least, the constant, which is minus 1. In other words, this is a polynomial, many terms, and I was not able to combine any of them. All I could do is rearrange it in standard form from highest exponent down to smallest, down to the constant. Okay? So that's my answer. I need to now classify this answer. And of course, we're going to start with the first name based on the degree. What is that first name? The degree 4. What's the first name? Quartic what? Polynomial, many terms. Again, some teachers refer to these 4 terms as a quadrinomial. I don't like that. I just call it 4 or more. I call it polynomial. All right. Last one. Is there a need for me to distribute? Yes or no? No, because it's plus sign. Plus sign doesn't change anything. The minus sign will change the signs, but the plus sign doesn't do anything. So I don't need to distribute the plus. As a matter of fact, I don't even need the parentheses here or there. I could just start combining like terms. And I'm going to start with my highest exponent term. What would that be? The highest exponent term. X to the fourth. This guy's going to go first. X to the fourth. There it is. Next highest exponent term. Negative 2x to the third. Is there any other x to the thirds to combine it with? No, so you just bring that down. Minus 2x to the third. Next highest exponent is x squared. Are there any x squares? No. Then the one after that is x's. Are there any x's? Yeah, there's a negative 2x right here and another negative 2x right there. Right here, they do not cancel. All right, right here you owe $2 and you owe $2. How much do you owe? You owe $4. In this case, x's instead of dollars. So negative 4x. Last but not least, we have a positive 5 constant that we're going to combine with this other constant, negative 5. What happens? They cancel out. So, ladies and gentlemen, this is my answer right here. And now we need to classify it. First name is based on the degree of 4. What's that first name going to be? Quartic. And how many terms? 3. So what do we say the last name is? Trinomial. And that's it. This is half of the test right here. Half of the test, no, I'm sorry, quiz. It's not a test. Half of the quiz is exactly what we just did right here. Adding, subtracting, classifying, and also there's a couple of questions where I just ask you to rewrite it in standard form, but we actually did that here on these problems anyway. We rewrote the answers in standard form. And also stating the leading coefficient and the constant. So we should be good with that first half of the quiz. Now the second half of the quiz is going to come from section 8.2. And 8.2 is all about multiplying a monomial times a polynomial. Okay? So far we've added and subtracted polynomials. And on this next section we're going to be multiplying a monomial with a polynomial. And the best way to get good at that is to review multiplication and compare it to addition and subtraction. So we all should know that we could combine like terms. 3x plus 2x is what? 5x. Exponents do not change because you're not multiplying. However, on number 6, this dot means that you're multiplying. Or it could be in parentheses also, but you're multiplying right here. So what's the answer to this guy going to be? 6x squared. Again, we are multiplying, and exponents come from multiplication, right? I mean, the thorough explanation of 3x times 2x, like if you said 3x times 2x, the thorough explanation would be that this 3 times x times 2 times x, and you could rearrange things. Commutative property of multiplication lets you switch things around. And you know that 3 times 2 is 6, and x times x is x squared. So that's your answer, 6x squared. Of course, you don't have to show that work. All right, you don't have to show that work. You just put 6x squared, and that's it. So how about number 7? Am I multiplying? No, I'm adding. So I'm combining like terms. So what's my answer to number 7 going to be? 7x to the squared. That's right. Exponents do not change. Why did the exponents not change? Because you're adding. The only time exponents change is when you're multiplying, right? Remember, exponents come from multiplication. And if you look at the previous one, number 6, we were multiplying. That's why x to the 1 times x to the 1 became x to the second, because exponents change when you're multiplying because exponents come from multiplication. If you're just adding 4 of these guys plus another 3 of those same guys, it's going to be a total of 7 of those guys. Right? How about number 8? Number 8, we are multiplying. So what's our answer going to be? 12x to the 5th. Perfect. Because when you're multiplying two terms with the same base, the x and the x, you end up adding those exponents. Again, let me give a thorough explanation like I did on a previous question. Let me give a thorough explanation on number 8 here. You see, 4x to the 3rd times 3x squared, you really have multiplication everywhere. And you could switch things around and say, okay, 4 times 3, that's how we got the 12 from, and x to the 3rd times x to the 2nd. So you end up with 12, x to the third times x to the second. If you remember rule 1 of exponents, it says that you add those exponents when you're multiplying with the same base. Now, even if you forgot that rule, you could think about what x to the third really means. It means x times x times x. And then you're multiplying by another x squared, which is another x times x. And if you add these up, it gives you the answer 12x to the fifth. So that's why we add exponents. It's just a little review, and we're going to need to know that on today's section. Okay, how about number 9? If I have 4 of these x to the thirds, could I subtract 3 of something different? No, it's like saying I got 4 apples and I want to take away 3 oranges. You can't do that, right? So what's my answer going to be? It's going to be exactly that. 4x to the third minus 3x squared. That's just a polynomial, guys. That's just a cubic binomial, to be more exact. Power, the degree is 3, has 2 terms. So that's just a cubic binomial. You can't really add or subtract any of that stuff. How about number 10? X times x to the second. X to the third. Too easy. So when you're multiplying, that's when exponents change. Okay? Right here you had an x to the 1. And right here you have x squared. Add those exponents, it becomes x to the third. So when you're multiplying, exponents change. Now again, on today's section, we are going to be distributing. Okay, now we should all know how to distribute. What's the answer to number 11? 6x minus 15. That's easy, right? The only difference between that question and what we're doing today is that you're going to have something like 3x times 2x minus 5. So what is that? What happens then? If you have 3x, you do the same distribution. 3x times 2x, that's 6x squared. Exponents change when you multiply. And then when you distribute over there, minus 15 with an x. And that's it. That's it, right? So that's what we're going to be doing today. And let's move on to today's homework.